Have you ever wondered what the number pi really means and why it's so important in mathematics? Well, prepare to embark on a fascinating journey into the world of pi. Pi is an extraordinary number that's been intriguing mathematicians for centuries. It's a mathematical constant represented by the Greek letter API, and it's one of the fundamental elements in various mathematical formulas. Pi is the ratio of a circle's circumference to its diameter, a relationship that remains constant no matter the size of the circle. This ratio is approximately 3.14159, but the intriguing part is that it goes on indefinitely without repeating, making it an irrational number. This unique characteristic of pi not only makes it a subject of curiosity, but also a crucial player in many mathematical equations. From geometry to trigonometry, calculus to physics, pi is omnipresent, helping us understand and shape the world around us. Now that we know what pi is, let's delve into its fascinating history. The history of pi is as intriguing as the number itself. This mysterious mathematical constant has been pondered upon and calculated by civilizations across the globe for thousands of years. Let's embark on a journey through time to unravel the fascinating story of pi. Our story begins with the ancient Egyptians and Babylonians. They were among the first to approximate pi. The Babylonians estimated pi to be about 3 1/8, while the Egyptians pegged it at around 3 1/7. These approximations were quite impressive considering the tools and knowledge they possessed in their era. As we move forward in time, we encounter the Greek mathematician Archimedes. In the 3rd century BC, Archimedes made a significant leap forward in the calculation of pi. He approximated the value of pi by inscribing and circumscribing polygons around a circle, a method that became known as the Archimedes method. This ingenious approach brought the approximation of pi to a level of accuracy unheard of at the time. Our journey takes us next to China, where in the 3rd century AD, the Chinese mathematician Liu Hui further refined the value of pi. Liu Hui doubled the sides of polygons to get closer and closer to the true value of pi. His calculations brought the approximation of pi to an impressive 7 decimal places. As centuries passed, the calculation of pi became more and more accurate thanks to the tireless efforts of mathematicians. The advent of modern mathematical techniques and digital computers brought unprecedented levels of precision to the value of pi. Today, we have calculated pi to over 31 trillion decimal places, a testament to human curiosity and ingenuity. But despite this, the number remains enigmatic, its digits showing no discernible pattern, continuing indefinitely without repetition or termination. From ancient civilizations to modern mathematicians, the quest to understand pi has been a constant pursuit. And while we've come a long way in our understanding, the journey to unravel the mysteries of pi is far from over. This enigmatic number that we call pi, continues to captivate us, inspiring further exploration into the infinite depths of mathematics. So, how do we calculate pi? Well, the journey to calculate pi is a fascinating one, and it involves diving deep into the realm of mathematical concepts such as infinite series and formulas. Now don't worry if these terms seem a little daunting. We're here to demystify them. Let's start with the concept of an infinite series. An infinite series is a sum of the terms of an infinite sequence. Think of it as a never-ending list of numbers that are all being added together. Now where does pi fit into this? Well, some truly clever mathematicians found out that pi can be represented as an infinite series. One of the most famous of these series is the Gregory-Leibniz series. Here, pi is the sum of an infinite series where each term is derived from a simple formula. The series starts with 4, then subtracts 4 divided by 3, then adds 4 divided by 5, then subtracts 4 divided by 7, and so on. As we keep adding and subtracting these terms, we inch closer and closer to the actual value of pi. But the Gregory-Leibniz series isn't the only way to calculate pi. There are numerous formulas out there, each with its own unique approach. For instance, the Nilakantha series, named after the Indian mathematician Nilakantha Somayaji, is another beautiful series that converges to pi. As we delve deeper into the mathematical world of pi, we encounter even more complex formulas like the Ramanujan series, named after the Indian mathematical genius Srinivasa Ramanujan. This series converges to pi incredibly quickly, making it extremely useful for calculating pi to a high degree of precision. So, there you have it. From infinite series to complex formulas, the calculation of pi is a journey through some of the most fascinating corners of mathematics. Each method represents a different way of understanding this mysterious and vital constant, and each brings us a step closer to grasping the infinite. As we can see, calculating pi is not a simple task, but it's a task that brings us closer to understanding the universe. Now let's explore where we see pi in our world. Pi, the constant whose approximate value is 3.14, isn't just a mathematical concept we leave behind in the classroom. It's everywhere, woven into the very fabric of our reality. Let's start with geometry, the field where pi first made its mark. The most well-known application is, of course, in the computations of the area and circumference of a circle. A circle's circumference is 2 times pi times its radius, and its area is pi times the square of its radius. But pi's role in geometry doesn't stop there. It's embedded in the formulas we use for the volumes and surface areas of spheres, cones, and cylinders. Now let's take a leap from the abstract world of geometry into the tangible world of physics. Here pi shows up in some unexpected places. In the laws of universal gravitation and optics, for instance, the constant pi plays a significant role. It's also a fundamental component in the calculations of wave mechanics, quantum physics, and even Einstein's famed theory of relativity. And what about technology? Here too, pi is indispensable. For instance, in computer science, algorithms that involve circular data structures or cyclical processes often incorporate pi. It's also used in GPS navigation to calculate distances on the Earth's spherical surface. In the realm of imaging technology, pi is used in algorithms that reconstruct images from scans in medical and industrial applications. From the orbits of planets to the lenses in our glasses, from the ripples in a pond to the architecture of the World Wide Web, pi is there, silently underpinning the world as we know it. This humble constant, just a simple ratio in a circle, is a key that unlocks a world of understanding. It's a testament to the interconnectedness of all things, a reminder that math is not just numbers on a page, but a language that describes our universe. From geometry to physics, pi is a number that connects us to the world around us. Did you know that pi has also made its way into popular culture? This fascinating mathematical constant has been referenced in a variety of ways, from the silver screen to the written page. Remember the film Pi by Darren Aronofsky? It's a psychological thriller that delves into the mysterious world of numbers and patterns. Or how about the novel Life of Pi? While not directly about the number, it's hard to ignore the symbol's presence in the title. Music hasn't been left behind either. The song Pi by Hard & Firm humorously attempts to sing out the digits of pi. Even in the world of competitive memorization, pi holds a special place. Rajveer Meena holds the current record, having recited a staggering 70,000 digits from memory. And here's an intriguing piece of trivia. Albert Einstein was born on Pi Day, March 14th, which also represents the first 3 digits of pi, 3.14. As we can see, pi is not only a mathematical constant but also a cultural icon. Pi may be a known number, but it still presents challenges to mathematicians. For instance, calculating additional digits of pi is no simple feat. With each added digit, the complexity of the calculation increases exponentially. Despite this, as of today we've computed pi to more than 30 trillion digits. Another intriguing challenge is finding patterns within pi's digits. Although pi is irrational, and its digits don't repeat or follow a discernible pattern, mathematicians continue to probe its depths, ever hopeful of discovering hidden mathematical truths. Over the centuries, there have been many breakthroughs in pi computation. From the ancient Greeks' approximation to the use of supercomputers today, each leap forward has pushed the boundaries of our understanding and capabilities. Despite its challenges, the exploration of pi continues to fascinate mathematicians worldwide. As we continue to unravel the mysteries of this remarkable number, each new discovery brings us closer to understanding the very fabric of our universe. In conclusion, pi is much more than just a number. It's a fascinating mathematical constant, with a rich historical background that spans centuries, from the ancient calculations of pi to its precise computation in the modern era. It's a symbol that's been applied in various mathematical formulas, playing a pivotal role in geometry and physics. Its presence in the laws of universal gravitation and optics is a testament to its broad application. The intriguing slices of pi's history and its unusual applications have found their way into popular culture, inspiring movies, music, and literature. The challenges it presents to mathematicians, such as calculating additional digits or finding patterns, keep our minds sharp and our spirits curious. The feats of memory, with individuals memorizing many digits of pi, showcase the human spirit's capacity for extraordinary tasks. So the next time you see the symbol pi, remember, it's more than just a number. It's a mathematical constant that continues to shape our understanding of the universe.